let's look at section 5.4, which covers circles. A little bit of background information about circles. It deals with the value pi. That symbol here is pi, spelled P-I. And so the ratio pi represents the circumference compared to the diameter of a circle. If you're not sure what the circumference and the diameter of a circle are, we'll cover those in just a few minutes. The first civilization to approximate the value of pi to find the area of a circle was in Babylon. So it was a Babylonian civilization. The first mathematician to try and approximate the value of pi was Archimedes of Syracuse. And then the first person to use the symbol pi to stand for this value is William Jones. So again, you won't be expected to remember this, but maybe it'll help you in Jeopardy someday. Now let's move on to looking at the vocabulary that we're going to be dealing with. They draw a diagram for this. So our circle is the entire thing, so the part, they just said NA. And that means not applicable. And so, definition of a circle is a set of all points, equal distance, so I'll just put the equal sign for equal, from a fixed point. Okay. The circumference of a circle is the distance around the circle, which with other shapes we call that the perimeter. And they label that as A up here to show we're going around the outside. The center of a circle is that fixed point of a circle. And so sometimes it's drawn in there, usually it's not, but it's understood to be there. They've labeled it as point D, or sorry, B for us. Now the radius of a circle is the distance from the center of a circle to a point on the circle. And they've given us an example SC up here. But obviously we can make this look like a wagon wheel and draw several different radii, that's the plural for radius, through here. So any line drawn from the center of the circle out to the circle is called a radius. And then the diameter of a circle is the distance from one point on the circle through the center to a point opposite it on the circle. So their example here is this dotted line D. So we're going from the left-hand side through the circle center to the right-hand side. And as you can see, we have from the left to the center would be a radius, and then from the center over to the right-hand side is a radius. So the length of the diameter is made by two different radii added together, if you want to think of it that way. Okay. So when we're looking at our formulas, the circumference, which again is a perimeter, the distance around a circle, can either be 2 times pi times radius or pi times diameter. And we just mentioned why, because the 2 times a radius is the same length as the diameter. And The area inside the circle is area equals pi times radius squared. Remember that represents radius times radius. And so I want to mention here to make sure in Hawk, so for your homework, you're going to, and many examples that they have in the book, use 3.14 as pi. And your calculators will have a button that has a pi symbol, which is on the left-hand side for most calculators above the exponent button, but it could give you a different answer for the problem you're working on because of rounding. 3.14 is a rounded version of pi, where the pi button is still a rounded version of pi, but it's several decimal places bigger. So you have a chance of being off 1 or 2 decimal places for larger figures, and then the Hawk's learning to count it wrong because your rounded answer isn't the same as what they expect you to have when you use 3.14 instead of that pi button in the calculator. So make sure you're aware of that. So let's look at an example of using these formulas. When working with circles, you need to determine the values of the variables r and d. Occasionally, you will need to determine the value of one of these given the value of the other. It is important to know if a problem statement is giving you the values of the radius or the diameter. For the next 2 problems, answer the questions based on the information given. So if we look at this picture, we can see from the center out. So they have given us a radius. So it says the value of which measurement is given. We just said that. It is a radius. And so the equation to find the circumference around the circle, when we have the radius given, is the circumference equals, so we'll use C for circumference equals, and that was 2 times pi times radius. And so our circumference equals 2 times, we'll use again 3.14 for the value of pi. And the radius here is 7. And so when we multiply those together, we get 43.96. And our units are in feet. So just like perimeter, we have singular units, just feet, not feet squared. That's for our area. Okay. Let's look at another example. Here we can see that the distance across the circle is given to us. So the value of 6 inches represents the diameter of the circle. And it says, do you need the R or the D to find the area of a circle? It's giving us that hint that the area of a circle is pi times radius squared. So obviously we need the radius. So before I even look at the problem, what I'm expected to find, what I always do is to make sure that I know what the radius is. If it's given, great. If it's not, I always put it next to it, because remember the radius is going to be half the diameter, and so it's going to be 3 inches in this case, because I can use radius for both the circumference and the area, but as you can see, we can't use the number for the diameter in our area formula. So I always go and make sure that I give myself the radius so I don't accidentally plug in the wrong number and get the wrong answer for my formula. So area equals our 3.14 times our 3 squared. And so we know 3 squared is 3 times 3, which is 9. So we have 3.14 times 9, which will give us 28.26. And now that we have area, it's going to become square inches. So again, be careful of what numbers you're using when you're finding the area. Make sure you're using the radius and not the diameter. Here's another example. Notice we have a compound shape here. And it says some complicated geometric figures contain circles or parts of a circle. Knowing how to identify the shapes that make up these features is a skill that you can develop with practice. And so it asks us what two shapes do we have. Notice here we have like a half a moon shape. It's a half a circle, which is called a semicircle. And so for the two shapes we have a semicircle and we have an upside down triangle. Okay. So the area formulas that we need, the area of a triangle is 1/2 times base times height. And then the area of a circle, we know, is pi times radius squared. But because we only have half of a circle or a semicircle, we have to make it adjusted for that with a 1/2 in front of it. So that's because it is 1/2 circle or a semicircle. So we have to adjust our formula there to compensate half of it missing. And so for our area of a triangle, we see 1/2, and it's upside down is the way I think of it. So our base would be here, which is the diameter of the circle, which is 4 inches, times the height, which they show us the height out here of 8 inches. And if we multiply 1/2 times 4 times 8, we get 16 inches. And again, that's inches squared, square inches. And then for our half a circle, we get 1/2 times 3.14 times radius squared. Notice we have our 4 inches up here for diameter, so our radius is equal to 2 inches. So we will put 2 squared up there. So we solve that 1/2 times 3.4 times 2 squared will give us 6.28. And again, we have square inches for our units. So then our total for the entire shape would be our 16 plus our 6.28. Which will give us 22.28 square inches. Good. Next, we have some shapes for you to figure out. And so if we look at these for a second, here we have a circle. Notice it asks for perimeter and area of each. So formula you can look up. Notice for number 7, we have 1/4 of a circle. So pay attention to what that means for you. the area. You're just going to use the area formula and then take 1/4 of it to come up with the area. But notice the perimeter. This piece here, we can find it by taking 1/4 of the perimeter of the circle, but then you have this left-hand side and the bottom side to deal with. So make sure that you add all 3 of those values up. For number 8, for the perimeter, notice we have 3 sides, and then you're going to find half of the circumference of a circle to be able to get this round piece here. And then when you're doing the area, you're going to think of this as a square with a half a circle being taken away. And so find the area of your square, subtract the area of half a circle there. For number 9, notice you have a half circle on the top and a half circle on the bottom. So for area and perimeter, you can use just that formula for the circle. And then you'll add your sides onto it when you're doing perimeter and adding to the area parts the area of this rectangle that's in the center. So pause the video and work on those, check your answers, and let me know if you need help. Okay, let's look at examples. The price for 3 different pizzas are shown in the table below. We have a 9-inch pizza, a 12-inch pizza, and a 16-inch pizza. First, we're going to find the area. Now, it's important to note that when they talk about the size of a pizza, they're talking about the diameter. So the first thing we want to do, since area is definitely in radius, is to make sure we have the radius. So I like to just say I need to forget about that being 9 inches and look at it as a 4.5 inch radius. Half of 12 would be a 6 inch, and half of 16 would be an 8 inch. And so those are the numbers that we're going to be using in our area formulas. And so for our small pizza, we have our area equals pi, which is 3.14, times radius squared, which is 4.5 to the 2nd power, and so when we do our calculations, we get that the area of this pizza is 63.59, and that is in square inches. So our 12-inch pizza, or we'll call it our medium pizza, we have area equals 3.14 times 6 squared. And so then when we do the calculations on that, we get the area of our medium-sized pizza being 113.04. And again, that's in square inches. So now when we look at our large pizza, we have to substitute 8 as our radius instead of 4.5 or 6. And again, I apologize for my sloppy writing. I'm trying to use the touchpad of my computer to write, which is kind of difficult. But we get 296 when we type this into the calculator. And again, that's in square inches. So now we have our area. Question B asks us to use a ratio to find the price per square inch. We know ratio is a fraction. The word per is where that divides from the top and the bottom. So it tells us we want price on the top and square inches on the bottom, which is our area. And so for our first pizza, we need to find the price in our chart, which is $7.25. And then that's per 63.59 square inches. And since we're dealing with money, we're going to round 2 decimal places, and that gives us 11 cents per square inch. Now let's do the same for our medium pizza. And so we have the cost of a medium is $10.25. And we found the area to be 113.04. Which, when we divide rounding to the penny, gives us 9 cents per square inch. Now let's look at the large pizza. We have $13.50 for the cost and 200.96 as the area. And so when we divide that, we get 7 cents per square inch. So based on those results, we can say with certainty that the large pizza, or the 16-inch pizza, is the best value because it is cheapest per square inch. So it's not the cheapest in cost, but when you compare it to the size of the pizza, it is the cheapest per square inch. The city is planning a fountain in the middle of a public park. The park is a rectangle, and the dimensions are 70 by 45. Let's give ourselves our park, green for the beautiful grass, and we have it 70 by 45. The fountain that they're putting in the middle is a circle with a diameter of 10 feet. I'm going to put the radius because I always like to make sure I get that number in there and not accidentally plug in 10 for radius when the radius is technically 5. So it's asking what area of the public park will not be taken up by the fountain. So they want all this area around here. So we're going to have to subtract the area of the park is length times width. So 70 times 45, which gives us an area of 3,150. And we need to take away from it the area of the fountain. The area of our circle is pi r squared. So we have 3.14 times our 5 squared. Again, make sure you're plugging in the radius, not the diameter. And that gives us an area of 78.50. And so let's put our units there of feet squared and add our units of feet squared to the area of the park. And so our total area that's not taken up by the fountain would be 3,150 minus the 78.50 to give us a total of 3,071.25. 0.50 square feet. Okay. Here we have parking lots, and the emergency room of the hospital has this half circle here for where the ambulance can drop off the patients right by the door. So we have, as you can see, a rectangle and a semicircle for our shape. And the dimensions are written already on our diagram for it, which is nice. We have 85 by 100 feet, and we do have a radius here of the semicircle of 14 feet. So the total area, we're going to have to add the two numbers together. Don't forget, since it is a half a circle, then we'll have to use 1/2 in the formula. So the area of our rectangle, we have 85 times 100, or 100 times 85, either way if you want to put it. Order does not matter in multiplication, and that's the commutative property that allows that. So we get 8,500 or 8,500. Make those a little bit better if I can. And we again get square feet. So then our area of the semicircle here will be adding 1/2 to it because it's half a circle, times pi, so 3.14, times our radius squared, which is 14. And if you plug that into the calculator, you will get 307.72 square feet. So for our total area, we need to add the 8,500 to the semicircle of 307.72 to get a grand total of 8807.72. Again, feet squared. Oops. Forgot my square unit on my semicircle. So the area of this entire parking lot is 8,807 and 7,200 square feet. The last example they have us is dealing with machine shop. It says they're making washers, and we have a chart of 3 different machines, 3 different inner radiuses, and the outer radius is the same. And so we have the area being empty that we need to do. And so notice the area of the washer is going to be the difference between the area of the entire outside circle, subtract the inside circle, because we have to punch out that hole in the middle, which is the size of the inside circle. And so are all the machines set up to produce the correct outer radius? Because inside of our story problem, it says we receive an order for an 80 millimeter wide washer with an area of 2198. So that's wide, so that would be the diameter. So here we have radius, which we know that the diameter is twice the radius. So 40 times 2 would give us 80. So yes, all machines would have a diameter across the washer of 80 millimeters. It says, without calculating the areas, which machine will produce the washer with the largest area? So remember, the inner radius is determining the size of the piece that's getting cut out. So the largest washer would be the one that has the largest space that's not getting cut out, which means the circle would be the smallest. The smallest circle would be the circle with a 10 millimeter radius, which is machine A. And then it says calculate the area of each washer and place the areas in the column 4 of the table. And so again, we have to subtract the areas of each of the circles for machine A, B, and C. So for machine A, we're going to do the area of the inner circle, which is 3.14 times 10 squared. I'm not going to write this all down. You could write it down on your paper if you want to, but 3.14 times 10 squared would give us 314 for the area of the entire circle. We have to subtract off that, we have to subtract that from, so let me erase it because we need to do the larger one. The area of the larger, that was the area of the smaller. The area of the larger one, which is 3.14 times 40 squared. Again, that's in the radius, so we don't have to divide it by 2. So 3.14 times 40 squared would be 5024. So 5024 would be the area of the larger circle without it being punched out for the circle to make it a washer. And then we already mentioned it's 314 for the area of the 10 millimeter circle. So the area of washer A would be 4710 millimeters squared. So 4710 meters squared. Plug into our chart. For washer B, we have the same outside radius, so we're going to start off with the same size outer washer. Well, let's call it a disc, I guess, until it gets punched out. Minus, now we're doing 20 for our radius, so 3.14 times 20 squared is what we'll subtract, and when we do that, we get 1256. So that leaves us with 3768 millimeters squared. So 3768. And then our third machine, and we have again the 5024 for the entire outside disc, and we'll punch out a hole that's 30 millimeters in radius, and so we'll do 3.14 times 30 squared, and that will give us 2826 being taken away. And so that gives us 2198 left for the area of that washer. And again, millimeters squared. Always remember your units. And then D, are any of the machines set up to create the washer size that was ordered? So let's scroll back up here. 2198 was the area that was requested, so that was C. So yes, machine C. So those are some application problems to areas and perimeters and things dealing with a circle. Again, if you have any questions doing your homework, contact me. Otherwise, I'll see you in the next lesson.